Okay, welcome back to our course on CNC and PLC programming. This is going to be the first module, and what we're going to talk about here is talk about the coordinates, axis, and motion that we need to become aware of, and we have multiple frames of reference that need to be considered for us to be effectively doing this. So as we start to get into this, and here I'll try and be including some example images of these types of machines that you will be looking at, both the machines and also the programming interface that we'll have. So that's just a representative of that. So now we're into this third part of this textbook. And so, like I said, we're going to be using the chapter designations that it's laid out. So starting in chapter 16, we begin the lessons on how to manage a programmed machine tool in a CNC world. It's a bigger job than putting parts into the setup and hitting the green button to make it all happen, although that's where you'll probably begin your career operating in a CNC. So before you get into programming, most likely you'll get some exposure by seeing how it operates and just being in that part of the ecosystem. It's about managing data, making setups, editing programs, and solving problems when they arise. So those are the skills that you want to make sure that you're going to be able to master. And in order to manage this level of responsibility, we must study some underlying techno facts, some of the things that go behind the scenes, and we will first learn about the systems that make it work. And so that's what we'll be talking about in this module 1, talking about chapter 16, and then module 2, where we'll be going over chapter 17. So always want to be thinking of one thing at a time. While this may look like technical beast, when taking one aspect at a time, the whole subject is easy to learn. And so I think as you start to get into the groove, you'll start to pick up on that. That's the way we will proceed in the introduction to CNC. And so this is, like I said, the third part of this machining and CNC textbook. The subject is broken down into individual units of learning, easily digestible, and learning to leading to competency. That's what we're focusing on. So after completing this course, which is what we're focusing on, part 3 of this textbook, you'll have the baseline knowledge, and you'll be ready to safely and confidently learn the setup and run your own CNC machine. So just as a caveat, and I already mentioned this a little bit, this is an online course, so we're not going to be able to fully grasp how we operate in these machines, but as best we can in a virtual sense, and also with this PowerPoint slide deck that we're working our way through, we'll do our best to help out with that. The textbook does provide some more information, and there's also some video references in the textbook that you can take a look at as well. So this is the outline for chapter 16, and we'll be going over some high-level thoughts on each one of these topics here. So first of all, we have the thinking about axis, different world axis standards. And so XYZ would be a common one. That would be for the linear axis, for rotary axis, A, B, and C. And having a secondary linear set would be U, V, and W. And then finally, having the rules for determination. So that would be the first item. Next, thinking about coordinate systems and points, trying to think of absolute and incremental values, trying to establish coordinates, plus and minus for two-dimensional activities, points for geometry and reference, and you can either have an absolute, incremental, or metric, and then conventions that are used in the programming commands. And so as we start to go through this material in our practice project work in the class, hopefully that will become a little bit more familiar. Third, we'll be thinking about the CNC machine motions, the axis movements, and the axis combinations, where we can be thinking beyond just a flat area. It could be a 2.5 or 3 dimensions. So 2.5, you can be thinking like have a layered way that you're milling out something, or a true 3D motion where you could be going anywhere. And I'll just use this terms X, Y, and Z motion. Then finally, polar coordinates, we'll be thinking in terms of absolute and incremental polar values, and finally positive and negative directions. Okay, that's a good place to pause. And so we'll break this up into pieces. And so that's the first increment for this chapter. Okay, let's go on and continue. We went over the introduction for this chapter. We went over the goals and the four different areas, and now we'll start to get into the details. And so the Electronic Industries Association defines 14 standard accesses. We're only going to be covering 9. And we saw that in the previous slide, talked about the last segment, where we have X, Y, and Z for linear, A, B, and C for rotary, and U, V, and W for a secondary linear axis. So unless it's a multiplex machine with several auxiliary rotary and linear axis, these 9 are adequate. So that's the reason why we're just going to be focusing on that. However, as manufacturing gets more and more complex, that may not be true. We have very powerful central processing units that are used in the equipment that we're programming. And so this may not always be the case, but for what we're going to talk about, especially for many of you, it's going to be a first blush experience. We'll just keep it simple. So identifying the machine axes, whenever you were assigned to a new CNC machine, the axes set must be identified as a first order of business, because as you're programming, you need to make sure that you follow the conventions of the machine the way it's determined. And so here are just a couple examples that you can be thinking of: a vertical mill, horizontal mill, or a lathe. And so you'll see the way that the axis orientation are laid out for that. So quick tips on axis identification. It's easy to identify the Z-axis. It's a spindle, or it faces the spindle. It's the drilling axis. And so keep that in mind. Then I'll apply the right-hand rule by pointing your right middle finger in the positive Z direction. Your fingers and numbers then form the orthogonal axis frame, and they're all at 90 degrees away from each other. We'll have a couple pictures starting with this next chart to give you an idea. Here's a nice way to be thinking about: first, identify the Z-axis. And so the Z-axis is your middle finger. It's parallel to the spindle axis and brings the work together and away from the spindle. Pointing your middle finger to the positive Z direction, your index finger and thumb form the other positive axis. So we can see it's labeled there. Here's another one. You could actually do this if you want, actually write on your fingers to give you another sense of what it is. So they're orthogonal, but not always level. All CNC machines use the XZ or XYZ frame, with each axis mutually perpendicular to the others. That relationship stays the same no matter how the axis set is rotated to suit the machine. Towards stronger or more efficient machines, manufacturers arrange the set any way convenient, but they don't change the interrelationship between the axes. And so we went through this before. We can see the fingers and how we can see that relationship between the different axes. So now for a serious example, we can think of a slant bed lathe. And so we're looking at this instrument and it's not flat. The x-axis on many turning centers is not parallel to the floor. It is slanted forward, so you can have easier access. This provides easy access to the turret for setup work, since the machine isn't as wide as level access machines. Plus, chips and coolant slide right off of the catch basin below. So this lathe world axis orientation is not level, but it's still an orthogonal set. So relative to each of the coordinates, they are orthogonal to each other. They're all at 90 degrees from each other. So thinking about the primary rotary axis, so it's not X, Y, Z, but A, B, and C. Whenever a machine features a rotary axis, we identify it in this way. If it rotates around a line parallel to the X, then it's the A axis. If it rotates parallel to the Y, then it's the B axis. And if it rotates around the Z axis, then we would be thinking of it in terms of the C axis. And so that gives you a perspective for that. So which direction? So to determine the direction of rotary motion, either plus or minus A, B, or C, that is clockwise or counterclockwise, we use the rule of thumb. It's based on the line about which the rotary axis pivots, X, Y, and Z. So you point the thumb of your right hand in the plus direction of the axis of the rotation, X, Y, or Z positive direction. And we have some figures below that will hopefully help to clarify that for you. All right, let's pause as we get into the next section. So